Okay, algebra. We are going to look at exponent rules today, but we're going to look at some multi-step problems, which means we're going to have more than one step for each problem. So if we think about our exponent rules, just to review, and as you know, pause the video and get your materials so you can take notes. Yes, you need to write this down. So if we think about our exponent rules, just to review, remember that when we multiply powers that have the same base, we add the exponents. A to the m times a to the n is equal to a to the m plus n. And notice, right, our base of a stays the same throughout the problem. And we know that when we divide powers with like bases, we subtract the exponent. So a to the m divided by a to the n is a to the m minus n. And notice again, our bases all stay the same. We also know if we do this subtraction problem and we end up with a negative exponent, any number to a negative exponent is the same as 1 over that number to a positive exponent. And again, the bases stay the same. We also know that when we take a power to a power, a to the m to the nth power, that's the same as multiplying the exponents, a to the m times n. And again, the base of the exponent does not change. And finally, if we take a quotient to a power like a divided by b, and we take that to the mth power, that's the same as a to the m divided by b to the m. And notice those bases stay the same and these bases stay the same. So, one other rule, or actually two. Any number to the 0 power is 1. And then remember, as long as that number is not 0. And if we have room for one more here, a number to the 1 power, well, that's just that number. So that can be kind of helpful to help us. So any number to the 0 power is 1, and any number to the 1 power is that number. Okay, so let's get into these multi-step problems now that we have reviewed our exponent rules. So let's see. Let's say we have our first example problem. You're going to label it example 1. Let's say we had 3x squared y cubed times 4x to the 5th y squared. Now, this is different than what we were doing before because we were only multiplying something like x squared times x to the 5th. Now, we basically have 3 problems in one. And remember that multiplication is commutative. That means you can multiply in any order you like. So I could, right, if these are all being multiplied, I could say, well, 3 times 4 is one problem, and then I'll multiply that by x squared times x to the 5th, that's another problem, and y cubed times y squared, that's another problem. So those two things are equivalent, and then I can just do the multiplication, remembering that when I multiply powers with like bases, I add the exponents. Well, 3 times 4, I've always known what 3 times 4 is. That's 12. That knowledge doesn't change. X squared times x to the 5th is x to the 2 plus 5, or x to the 7th. And y cubed times y squared is y to the 3 plus 2, or y to the 5th. So now I have a simplified expression. Okay, let's look at another example problem and make sure that you are pausing the video and writing stuff down as you need to. And maybe I'll, kind of make this like a big thing so that we remember this is a really important property of mathematics. Okay, example 2. This, let's see here. Let's say we have 12a cubed b to the 7th power c to the 5th power over 15a b to the 4th c to the 10th. So there's a lot going on in this problem, right? We have 12 over 15 that we have to reduce, and then we also have some a's, some b's, and some c's. And remember, all of this work only works when the bases are exactly the same. So let's see here. I'm going to take this problem, and you pause the video and write it down, and then come back when you've written it down. I am going to take this and break it up into 4 separate problems. So if you remember, when you multiply fractions, you multiply straight across. So we can actually, it may sound morbid, but you decompose the fraction. So we can make this fraction instead 12 over 15 times a cubed over a times b to the 7th over b to the 4th times c to the 5th over c to the 10th. So essentially we have taken this one problem and we've just pulled it apart so we can view each piece separately. Okay, now I'm going to change colors on my pens because when I think about 12 over 15 and I have to reduce that, I'm still going to reduce it in the way that I know how. And if I think about 12 and 15, what number goes into both 12 and 15? Well, 3 does. 12 is the same as 4 times 3, and 15 is the same as 5 times 3. And any number over itself is 1, so I can cancel these 3's out and just say that this is 12 to the 5th is 4 over 5. Okay, now I'm going to look at a to the 3rd over a, and you may recall this rule here. Any number to a 1 is that number. We don't always express that 1, so this is really a to the 1. Now you can think about these a's expanded out, a times a over a, and those a's cancel. Or you can think about this as a to the 3 minus 1, which is a squared. In either case, you get a squared. So the second part of our problem is a squared or a squared over 1. Next, we'll deal with the b's. Now, we could expand these out, or we could do our subtraction. B to the 7 minus 4, that's b cubed. So I'm going to have b cubed over 1. And then finally, I deal with my c's. Now, again, I could think about this expanded out, or I could do the subtraction. I like to think about it expanded out. I just visualize 5 c's in the numerator and 10 c's in the denominator, and canceling them all out. And what I end up with are no c's in the numerator and 5 c's in the denominator. So I get 1 over c to the 5th. And then I do my multiplication. I recompose my fraction now that I've reduced it all. So I get in the numerator 4a squared b cubed. I don't need to write times 1 over 5c to the 5th. So that is my simplified fraction. And remember, we always express our answers using positive exponents. So if you were wondering why I said c to the fifth was in the denominator rather than saying c to the negative fifth, that's because I always express using positive exponents. Okay, we are going to do one last example here. Example number 3. Make sure you are writing this down. Example number 3 is taking a multi-step problem and taking it to a power. So we have, let's say we have 5 p to the 9th, q to the 11th. And let's say we're going to take that whole thing to the 3rd power. We could think of this a couple different ways. We could just think about it as distributing the exponents, and remember that 5 is the same as 5 to the 1. So we could distribute the exponent to each one of these. We could say, well, this is, 5 to the 1 times 3, and p to the 9 times 3, and q to the 11 times 3. And that's probably the fastest way to think about that. That would be 5 cubed p to the 27th, q to the 33. So that would be one way of thinking about it. You could also express this as 5 to the 3rd as 5 times 5 times 5, which is 125 p to the 27th, q to the 33rd. That would also be an acceptable answer, and you would get full credit for either one. But, we have that old saying, when in doubt, expand it out. So if you took 5p to the 9th and q to the 11th, and you took that whole thing to the 3rd power, and you wanted another way to think about that, well, what that means is you are taking 5p to the 9th, q to the 11th, multiplying that by 5p to the 9th, q to the 11th, and multiplying that by 5p to the 9th, q to the 11th. And now what you have here are multiplying powers with like bases. So you could think of this as 5 times 5 times 5, and p to the 9 times p to the 9 times p to the 9, and times q to the 11, q to the 11, q to the 11, and then add those up. So we have 5 to the 1 plus 1 plus 1, 5 to the 3rd, p to the 9 plus 9 plus 9, 3 groups of 9, 3 times 9, 27, and 3 groups of 11, 33. And you see we come to the same answer, and of course you could certainly do that multiplication out and get 125 p to the 27th, q to the 33rd, if you chose. Or both are great answers, and I would love it if you give me either one of them. All right, folks, that is our notes for today. After you finish watching this video, you are going to go to deltamath.com and do the assignment there titled Exponent Rules 3. Your homework for today is at deltamath.com, and you are going to do Exponent Rules 3. That is your homework for tonight. Okay, see you in class tomorrow. Bye, guys.